Now, if A and B are independent, then we have to prove that A and B complement are also independent. A complement and B are independent. A complement and B complement are independent. So it is very simple to prove A and B complement are independent, since P of A intersection B complement equal to P of A into P of B complement. And we know that P of B complement is 1 minus P of B. So accordingly, we can prove that P of A intersection B complement equal to P of A into P of B complement. So on the same line, P of A complement is 1 minus P of A. Therefore, P of A complement intersection B equal to P of A complement into P of B. And accordingly, P of A complement intersection B complement equal to P of A complement into P of B complement. So we can prove by using the theorem on independent, that is, if A and B are independent, we can write this as P of A intersection B equal to P of A into P of B. Now there are two more concepts in this independence. One is pairwise independence of three events, and the another one is mutual or complete independence of three events. So in some references, it is known as mutual independence. In some other references, it is also called as complete independence. For pairwise independence of three events, if A, B, C belongs to omega, then we can say that these are pairwise independent if and only if these three conditions have to satisfy. So the first condition is P of A intersection B equal to P of A into P of B, P of A intersection C equal to P of A into P of C, and the third condition is P of B intersection C equal to P of B into P of C. And as far as this mutual and complete independence of three events is concerned, we have to add one more condition irrespective of these three conditions. That means for pairwise independence, these three conditions must be satisfied. And for mutual independence, we have to add one more condition, and that condition is P of A intersection B intersection C equal to P of A into P of B into P of C. We can see this by using one numerical example. So suppose this omega consists of these four sample points, and assume that each point has probability 1 by 4, and A consists of 2 points, B has 2 points, and C also has 2 points. So we have to examine whether these are what type of independence are these. So whether these are mutual independence or these are pairwise independent. So we know that A consists of two sample points, therefore P of A is 2 by 4. So accordingly, P of B is also 2 by 4, and P of C is also 2 by 4, because two conditions are favorable and the total number of conditions in the sample space are 4. So therefore P of A equal to P of B equal to P of C equal to 2 by 4, that is 1 by 2. And what about this A intersection B? So in A intersection B, there is one common point. In A and C, there is also one common point, and there is one common point in B and C, and that number is 1. So therefore, one case is favorable for all these events, and the total number of cases are 4. Therefore, P of A intersection B equal to P of A intersection C equal to P of B intersection C, and that is equal to 1 by 4. Therefore, P of A intersection B is what? P of A into P of B, and P of A is 1 by 2, P of B is 1 by 2, and this left hand side is 1 by 4, and the right hand side is 1 by 4. So this equality holds. So on the same line, this second equality also holds, and the third equality also holds. Therefore, all these three conditions for pairwise independence have been proved in this case. Therefore, initially, primarily, we can say that these three events are pairwise independent. Now check for the last condition. So what about P of A intersection B intersection C? In all these cases, one number is common to all. Therefore, A intersection B intersection C is 1, and the total number of possible cases are 4. Therefore, we can say that P of A intersection B intersection C is 1 by 4. And if we check this, P of A intersection B intersection C equal to P of A into P of B into P of C. So we can say that this is 1 by 4, and this is 1 by 2, 1 by 2, 1 by 2. So that is 1 by 8. And 1 by 4, which is not equal to 1 by 8. Therefore, we can say that this is not mutually independent, but this is pairwise independent. Accordingly, we can take a call whether this is pairwise or